All right, so this is our second day of finding equations. So this one, instead of giving us a slope, they give us 2 points to find. So the first point is -4, 7. So that is left 4, up 7. So there's our first point. And our second point is +4, +5. So that is right 4, up 5. So we now have a line between them. So what we're going to do is we're going to count how many down and how many over does it go. It goes down 2, over 1, 2, 3, 4, 5, 6, 7, 8. So down 2 over 8. Well, if you think about that as a fraction, that can reduce down to -1 over 4. So if we go down 1 over 4, down 1 over 4, we now have a line where our slope is -1 over 4, and you will see where it crossed the y-axis is right here at +6. So looking at number 2, same thing. The first point is +5, +8, so that is right 5, up 8. Problem is that this graph doesn't quite go up to 8, so let's change that. Instead of 5, 8 to 5, 7. So that's +5, +7. So we're just going to put it at the top of our screen. And the next one is +5, +1. So right 5, up 1. You will notice that I don't go left or right on this. This is a vertical line between the 2 points. So it goes up 1, 2, 3, 4, 5, 6 over 0, which is an undefined slope. Remember, for undefined slopes, you go according to what the x is in that equation. Well, the x in both of them is 5, so this equation is x equals 5. You know that it will not have a y in this equation because it never crosses that y-axis. It only crosses the x-axis. So it is x equals 5. Our next one, our first point is 3, 1. So that's right 3, up 1. And our second point is 3, 8. So that is right 3, up 8. Again, I can't go all the way up to 8, so we're going to change that to 7. So right 3, up 7. But you'll notice, again, I have another undefined slope. Again, it's only going through the x-axis, so it's x equals 3, since 3 is what's common in both coordinate points. So what we're going to do is we're going to take one bit of information and show you what it looks like in a table, in a graph, and then in an equation. So in words, a cable car starts at a height of 700 feet and is descending at a rate of 30 feet per minute. Please keep in mind that descending means negative. You're going down. So at 0, it starts at 700 feet. So it's starting at 700 feet, which means at 0 time, it's at 700 feet. At 1 minute, it goes down 30. So 700 minus 30 would be 670. At 2 minutes, going down by 30, it'd be 640. And at 3 minutes, it would be 610. So in a graph with really big numbers like this, it's kind of hard to do. But we have 1, 2, 3. Those are the numbers that we're working with, because remember 0, 0 is always the starting point. And 700. So I'm going to make a break here to show that it is not starting at 0, 0 on this graph. What it's going to be starting at is I need to get up to 700 going up by 30s. So if I start at 700 right here, then this will be 670, 640, 610, and so on. So 580, 550, 520, 490, 460. All right, so our first point is 0, 700. So at 0 minutes, we're at 700. At 1 minute, we're at 670. At 2 minutes, we're at 640. And at 3 minutes, we're at 610. And it keeps going. Okay, so our last one is in an equation. So y equals. Well, we know that it is consistently going down by 30 every time on our table. We also know that it told us in words that it descended at 30 feet per minute. And we also saw in our graph that it's going down by 30 per minute. So negative 30 is our slope or our rate of change times x, because x is the number of minutes. So you could plug any minutes in there to find out how far up the cable car would be. And it told us that it starts at 700 feet.